Hello everyone, this is Janer. Yep, I hope everything is fine with you. In the previous video, we have started designing the ESP32 smart screen board. Um, Before we get started, let's check the audio and the sound. Video and the sound, if everything is okay, so we can continue. It's very cold in Sweden, it's like -8 degrees, unfortunately. Let me switch to stream. Yes. Is everything okay in the yep. Is everything okay in the live stream? So do you see it well? Is it clear and understandable? Yes. You can get your coffee cups as well. I'm a bit tired actually. I needed a cup of coffee before I get started. So this is actually where we are at the moment. So in the previous videos, I have completed actually designing the schematic. I can just quickly go through it. So this is where the MCU is, the connector, UART, boot option, reset button, and the screen. We have 4-inch LCD with touch control. We have the power. I have explained this actually in the previous video, the second video. You can check it. And this is the sensor interface or the sensor sheet. And there is the interface, micro SD card, QWIC connector, and sorry, and the interface connector. Why? YouTube sounds. There is some. Oh my God. I think there's some problem in my internet at the moment. Maybe it's not fast enough. But I hope everything is okay actually from your side. Let's see. So this was where we were actually in the last video. So I have done these actually small changes in the last video, and then I actually imported all these components to the PCB. Uh, I'm not gonna do it now, but I will show you now how it is. So you just go there, go to Design tab, and then you say Update PCB document. If you have more than like one PCB document, you can choose just that particular one, and then all the components will be transferred to this PCB file. So I have just actually updated this PCB, and like all these components came, but I haven't done any actually any adjustments so far. The first thing actually before you start designing a PCB is to actually set the rules in Altium. Let's see if we have it set. No, it seems we have some actually settings that I think we have inherited from another design, but I will delete it. Yes, there are some adjustments I see for another board that I have designed. But in case actually you don't have these settings, and probably the default settings are very like different. What you need to do is you need to go to your PCB manufacturer's webpage, and then you need to like open their capabilities. You just need to actually set all these rules one by one. Um, let's, for example, do some example with you. For example, the drill and hole size. It says the smallest is 0.15 millimeter. Let's check. The hole size, it should be like 0.15 actually. It's here. And then the maximum one was, I guess, 6.3. That's not very important, but minimum via hole, this is important. There's a remark here. So 1 to 2 layer PCB 0.3 millimeter hole size and 0.5 millimeter diameter. For multi-layer PCB, which is more than 2 layer, like 4, 6, and so on, it can be like 0.15. And wow, zero via diameter is like 0.25 millimeter. This is really, really small. But let's see. And then you go to routing vias, and I guess this is already set for us. Like minimum via hole size, maximum, and the preferred one is this one, 0.25. So you basically set your limits. Um, Okay, and then there is also just one more ring, one or more rules. Like the clearance is important. So the JLC actually supports the clearance and the width. Yep, clearance is here. You can find them actually like via to via, hole to hole clearances in Altium by just like clicking advanced, and then like from track to track, from track to arc, from track to SMT path. So this is how you actually adjust. If you see there are like some of them are different, because if you set from here, it will just set all of them to the same value. That's why you should set them here one by one. But after you set these values, what you should do is actually you should save all these settings actually, not to enter it again and again. So what can you do is that you just right click to anywhere in the left pane. So you just say export rules, and then Control A, just select all of them, and then just save this actually as a rule, like to anywhere. And then after you save it, you can import anytime. You can just say it like this, import rules, and then which rules you want to import. And then I usually, when I just start from scratch, I do like import all of them. Probably not all of them is saved, and then not all of them will be imported. So, and then you can just select the one you saved, and then that will be there. Yes, this is how you set up rules. Basically, it's very quickly I explained. When you're designing the PCB, the placement is very important actually on the component level. So that's why we will need to actually adjust the component placement or place them first and then do the routing. Before actually I do that, there is one thing I don't like. I was doing actually this design on my laptop at home. So there, the default settings are not changed. So if you see this is Times New Roman or like stroke, the default actually font style, which I don't like actually. I have never used it. I usually use this one, which is Calibri. I don't know why it is not showing here like this, but it is Calibri, I know. And then the size is always this one. You can go down to 1.6 millimeter. That's how the biggest JLC can actually produce, or it will be visible under that. Um, if it's smaller than 1.7 or like 6, it will not be visible, and then there will be like discontinuities in the ink, so in the silk screen. So you don't want that. So you shouldn't make it too small, so to say. And then what I'm gonna do is there's a feature in Altium that you can select many components or many things at once. So you just right click, find similar objects, it's text, designator, same, and you can select this one, it doesn't matter, but the text height, they are same, and then it is like strong for font, yes, and then apply, and then you see all of them are selected now. So I can go to the right pane to the properties actually panel, and then I can change the true type, and then I can change to Calibri, and then I can change the text height to 1.7. That's like mostly ideal actually. Yes, you see all of them like changed at once. Uh, no, filters will not work actually like that. There is no designator option to select it. So you just need to select components like this and then you need to play with the designators, but that doesn't work unfortunately. That's why I don't like it. And there is no designator option, as you can see here in the filter. So the best way is to do actually find similar objects for this case. Um, so I have added this actually um, connector, which goes to the bottom breakout or like docking station, so to say. And then there is the matching one, of course, that should be a bit longer or taller. So I will need to check the actually length of this if it is suitable, and then I will see it. Yeah, PCB filter can be an option too. Let's see if I have it open. PCB filter is, yeah, you could select it from here too. That's like more or less the same thing actually. It does the same. It is the same ideology actually. Apply to all, and then you mask it or select it. This is actually advanced than this like the option find similar object, and it's very useful. Thanks. And then yes, so the placement of this one is very important. So we need to actually place it to the middle exactly because I want geometrically on the middle exactly. But I need to see actually where the middle is first. Let me set my actually origin to this point. This is important actually when you are assembling the boards because it should always start from here, 0 and 0 origin. So 0 x and y axis. Edit origin set. So if you don't see this actually like ring, which means it doesn't snap, you should open the snap option and then enable the snap option, and then it should snap to this point. Otherwise, it might actually be shifted a bit. And then yes, let's continue. Let me check what's my actually size. I want to do this. There are different layers I usually use for different things, and then it's quite useful when it is like very complex designs or so on. Let me just check what is the board size. You see, this doesn't actually line up very well. I need to see why it's like that. Just yes. And then I just need to adjust this. But what is this green one? Uh, why? Why do we have green here? Okay, I see. I see the problem. I guess this is drawn in the component itself. I didn't draw this component. My colleague did actually. Um, so I can't actually modify it at the moment. So in the live stream, but anyway, I will do it later. What I want to do is I want just to find the middle center of this board. What I can do is I can just put guide manager and then like uh, sorry, vertical guide, but I don't know where. So I need to just find the X. So this one, let's see if it supports mathematical expression. Yes, it does actually. So this is the middle point of the board. Since this is the starting point, and then this is the middle point. So I just need to, yes, you see, it's like very well properly aligned actually to the middle. But I see this is not aligned so much. Is this a Isn't this a problem? I don't know. Maybe I need to check it. This is an important thing actually. Yes, I cannot move that one either because this step file, this LCD and this connector are together in a component, which I don't like actually. I will change it, but later after the stream. But I see one thing actually, I need to move this one down so I can have it here, but maybe not so much. So I can route this signals from here. But maybe what I can change is I can actually change the signals to these ones, and then I can get the signals from here. So you need to adjust your layout all the time. But there is one question, let me ask you. Uh, this USB connector will be blocked if we put it here actually. So shall we put it to somewhere else maybe? I also see that this is not actually going to the bottom exactly. I think I need to just go a bit more. I guess this will be okay. Tools, board shape, define board shape. Yes. Oh, perfect. You see? Yep. What I'm thinking, this FPC will go under the PCB, and then it will come out from here, and then will be connected to the FPC connector. I have taken taking a look. I have saw the schematic of the Tesla Roadster, but I haven't checked actually fully because I've been actually checking those schematics a lot from TI and so on. So I know a little bit. You can actually analyze it, but there is one thing that without proper knowledge and then like lab equipment and setup, it doesn't matter actually what you have as a schematic on your hand. You can find those schematics easily normally, or you can create it. You need to have the experience and the knowledge to understand it. And then I will just move it like this. I will just move it like this. Of course, these pads are important. Yep, I think it's gonna be okay now. Yes, but I'm not sure about this USB connector. Actually, I'm so to say like I was not like amazed actually they have released the schematic because even though you have that schematic, you cannot easily actually recreate that circuit like because if you have a different car, you need to like work on it a lot actually. But the thing is, it can give you a lot of idea like how it is working and so on. So that can be a good thing actually to check it, to study it. I think so far I have done enough actually study for those type of circuits. So I'm not interested so much anymore. I'm really busy nowadays. Like also my work side is like too busy at the moment. At ABB, we have new designs, and then I'm assigned to a new circuit. Yeah, this is all good. So I want to collect these actually to the relevant places. First, what I will do is I will just do split vertical, and then I can just select the components. Uh, for example, I know this one. Where is it? When you select the component, it should be also selected in the PCB from schematic, but cross select mode is enabled, but I don't see it. Don't we have this component here? Strange. Let me click to anything else. That's also strange. Why? Isn't it this? It's not this power board. It's another power board of another. Okay, it was another project's schematic. Yes, this is the D3, and then just let me take it like this, and then Yep, these ones, I just take it like this. Oh, you see, it was spread actually around. There are different actually techniques that they always combine this, but there are different techniques. I usually do it manually. Uh, if the circuit is very big, you can use actually Altium rooms and then feature, and then you can combine them. I don't know why these are locked. This shouldn't be locked. Also, this shouldn't be locked. And then this one, except this one. Oops. Do you do the same usually when you design a circuit? Like, do you collect them in the same way? And then we can have it here. And then this one. I don't know why these are all locked. Is it like the power ground or something that's locked? Otherwise, it shouldn't be locked actually. Yep, this is the power section. I have now selected all of them, and then I will actually simplify it or place them later. But let me take them like this first, because the power is actually on the USB type C output, so that's why the power components should be somewhere here, always close to the power input. And then this one is okay, but let's check this interface if you have anything actually. Okay, this is the micro SD card connector and these two resistors, and also C34. Where is C34? Oh yeah, it's here. Yep. So, and the QE connector, it's this one, and the coupling capacitor is this one. Just put it next to it. Yep, and this one is okay too. So let me go to sensors, and this is the accelerometer. Um, oops. It is usually a lot of manual work sometime actually you need to do, but it's worth actually. It requires actually this effort. If you don't do it, then you won't achieve a good circuit. Uh, the problem I had here is actually I was designing this circuit actually before, so I had transferred them already. That's why their designators have have changed, and that's why they are like in random places. Otherwise, we wouldn't see actually this untidy placement. It's here. It is here. This is a microcontroller, right? So we will need to program this one too. But I put it here as a group, so and then I will try to find a place to it. This circuit is okay too. This one, let me check. Yes, I just put it like this. To D4. Yep. And then we did the power. We did we do the screen? Let me check the screen. I prefer this actually to be on the. Oh, they go from two different resistors, unfortunately, so I need to remove one of it. Is it either these ones or the or the ones on the MCU side, you see like the screen has these actually like SPI connection and chip select, and the also I2C for the touch screen. But as I understand, they have these resistors actually doubled. So this I2C is okay. No, I2C is off. So I need to remove that one too. Okay, so we remove it. Maybe not for chip select. I guess chip select is controlled by, no, yeah, chip select as well. Yes. Okay. And then we need to update the PCB, automatically create, just execute. What is P3? Ah, I know P3. If you cross prop it, yes, this one. The footprint is missing, although I had designed it actually very recently. I don't know, I'm losing the library. I'm gonna draw it later. Yes, let's skip that one at the moment, but I guess those components were removed anymore, so we don't have them. The screen, yes. These three components, where is it? Yes, 3, 4, and they're already here, so they're in the relevant place. This one, the boost converter for the screen LEDs, backlight. So just let me take it like this. I will do the placement one by one later. Just I'm collecting them actually to draw it or to place them easily, so I know where they are. And then this four, and there should be, oh yes, they are here. Yep, we have taken this one, and then this page. Reset button. Where is the reset button? Yes, this two T1. No, it's just actually. Where are they? Ah, yeah, they're here. Yeah, our reset button. Yeah, might be somewhere here, but we will check. UART connector. Where is it? Yeah, it's here. And then the boot option. Boot option is just a jumper. That's better. Or maybe we can put a button because the thing is, it might be needed actually. So I just delete this one. I just do the same board, same design. Just select and just by pressing shift you can drag it and then control and then just boot here like this. So it's gonna be, yes, we will just need to check it later that if uh, there is an internal plop or something that's needed or not, but we can actually just disable the placement of this 10K and then we can see it. So this will eliminate the bouncing, right? So there will be glitches when you press the button. Uh, the so you will eliminate these actually glitches. It depending on the actually capacitor size, it can vary this effect because sometimes it might be too big that you will not actually have this fast switching. So that's why you should be careful, and then maybe you can measure it with a scope. Usually like 1 nano, 10 nano is okay. You might do some filtering in the software as well. There is an option reposition selected components in the tools section. Let's see. Reposition. Let's reposition. I don't see anything like this. Okay. Do you see anything like component placement? Yes. Position selected components. Okay. Let's select just the component. Let's see what will happen. Actually, except this one. Uh, it seems in PCB side. Yes, it's I'm already in the PCB side. And then reposition selected components. Okay. It it was selecting one by one. What happened? I don't know. Reposition. That's something else. It doesn't distribute automatically, I guess. Reposition. I guess it just yeah. But you can do like arrange within room, arrange within rectangle, arrange outside board. This should be the option actually if you have a room because that's better. Oh, PCB layout replication. What is that? That I think this is a new feature. Anyway, I'm almost done with the placement, but I need to decide where the connections are. So this is the QE connector. Shall we have the QE connector on the same side with the USB? This is a question. Maybe we can have it on this side actually. Maybe it's better. But where will be the battery? That's an important question. Maybe we put the battery on top of this circuit actually. So we just lie it like this on top. Uh, if we have it somewhere here, maybe. Okay, maybe we take the Q connector a bit down there, and then this USB connector somewhere like this. Yeah, so together on the right side. Okay. Um, this was the battery, yeah, power section. So let me just take it here as well. This is the EST diode required for the EST. You know, we are like always charged with the EST, so you need to put it. So let's try to place them one by one. But I think before we should have this power somewhere here like this. So just I'm gonna take them like this, yes. And then uh, this is the load switch, and load switch has this C25 close to the power input, so which is the battery in this case, and the R61 should be, oh, it says it's between 3 and 2, might be like this. Okay. And then the LDO, we have this 3.3 LDO. It is, let's see, so C28 should be like this, C27, yep. But where is the USB VCC? Okay, USB VCC is here, so I can rotate this just like this, and then they will have this same connection. But maybe it's better like something like this. Okay, C29 and C30, it's on the output. Yes. It's closer to the power and the ground pins, right? So This will be the so I can leave it just here for now. And then this battery, this is also important. I have two battery actually options, battery connector options. I don't know if I need to use both of them, maybe remove one of them. One of them is the small one, which we already have the actually battery with this connector, and this is very common actually in the field, let's say, like Arduino and SparkFun, like they all use this type of connectors. But yep, let me just put them aside. And then this R60. We have this actually battery protection. Normally, these protections actually are on the battery. There's a small circuit on the battery. You can see them actually. I don't know if I can show you, but you can check them actually. They are visible. But I just put it in case if there is any need actually. So it's always good to have extra protection. So C15, it's there. What does this actually do? It like they just there's a switch and then it actually disconnects the ground from the battery. So there's a series switch in series with the battery in the ground connection. So our actually circuit's ground is here, and this goes to this connection of the battery to the ground of the battery. And it has these protections like overcharge or like detection, release, over discharge, release voltage, over current, detection current. This is so nice. So you can get like different ones with different parameters. And then C26, C21 should be on the output of the battery. Yes, it is like it should be something like this. Then oops, no, not that way. I didn't like it how it turned out. Maybe like this, yes. So we can have this ground here. Okay, this is good now. So like this. Of course, it can change depending on the still like actual layout. And then 21, that's in parallel as well. I put always like different sizes, like 1 microfarad, even 10, like 100 nanofarad is always good, because there is this frequency curve actually where you get the most when you combine all these um, capacitors with different uh, values. And then we have the charger, and the charger is here. So the R62 iSet is here, but maybe can be like this as well because this is an iSet. It actually sets the um, current limit for the battery. So I want this to be accessible as much as possible by the user if they want to adjust their actually own limiting. Or what we can do is like we can put more of these actually resistors with different values. We can just put a jumper for the user and then they can just jump or remove the jumper and then they can have different settings easily. This might be a good idea. And then this R63, where is it? Uh, so let's say it's here. And then we have this R64, SPVCC, and then C32. It can be like this. And that's it. I don't know what this R6, R6, where is, yeah, R6 is here. Should be like this. Or maybe I do it like this. I line them up like that, so I can have this connection from there and this connection there, and then this connection just going straight to here. It might change a bit, so it's not the final, but so still actually thinking about it and like doing some simple adjustments. And this one, the switch 1 to 3 component, yes. So this should be on the battery enable, which is this IC4, yep, and the VSPV bus. IC4, where is IC4? Ah, it's there already. Let me just take it here. So this will control IC4. I think we can put it like this. R59 is like connected from, yep, in between there, and this one is, yep, can be like this. So we have this battery enabled going all the way like this, and the battery goes there, which is a nice thing. And then USB-V bus. Maybe this can be like this depending on the situation, or like this. And then we can also turn like this, so we can still have this ground actually, but we will see when the actual placement is done. So if we put these actually connectors here, do you think we shall put the SD card connection here, or like maybe here? And I have drawn the SD card, actual SD card, and I put it actually so we can easily see it, like when we put it to the product, how much it will extend outside, protrude from the shell. We see it obviously. But we can have this actually curvature on the shell, so maybe we can go in a bit. I'm not sure if that will be very like nice. So it is usually good to leave a bit outside, and then user can pull it and then put it back. And this was, yeah, for them. Yeah, I think this is good. How is it going for you guys? So is it like understandable? Do you enjoy it? Do you like it? Please make some comments. And the battery will be, that's not decided yet, the battery. But I am now thinking if I should take cubic here, because it will be too much actually on this side. And then let's try to line up all these sensors. Yep, it is this one. This is a nice sensor from Bosch. What is it? Yep, it is this one. Probably will not be placed. Yep, this one is placed, but not the other one. Yes. Yep. I think it's gonna be 4-layer board, so we will not have so much problems with it. Maybe can be a little bit closer. So There is only one thing actually here we need to consider. If we need to make an like slot and opening like around this temperature sensor, like not to get affected from the PCB temperature itself. So we need to check that one. And then this is the accelerometer. Okay, R45. Actually, 0402 would be better here in this board, but I don't want to actually like get the hassle with these small components because we cannot handle it very well. And then yep, so we can have it like this, optional too. So this is optional as well. Don't worry about these designators. I'm gonna actually adjust them later. And then we have CN17. Yes, the MCU we did. I think it can be placed. Yeah. Oops. Both of them are selected at the same time. Maybe like this. So if we go and make a connection with some power plane and so on. Yes, guys, how are you? Are you there? Like no one is writing anything. Um, this is the light sensor. I found I have drawn the actually schematic for it as well, and the symbol. So it will be a 90-degree light sensor. You're good. You're good. Yes. So the distance is important. I need to have the mechanical 3D file, and then I need to adjust it. Otherwise, we will need to use some sort of like stand of um, I don't spacer, which need to be checked. Maybe we can 3D print something, but anything extra adds like extra effort and extra money to the product. So that needs to be checked careful. That's why I will not place this one. I will just leave it here. I can design it with the mechanical engineer. I can just adjust the placement of it. What is this? Why I haven't found these ones? Anyway, and the IO expander. Yes. I use this product, this MCU actually, in one of my sensors, which we developed actually. It's called Smart Shunt Pico. It's a very small actually shunt current measurement sensor, shunt based. Let's put these ones. So like 100 nano to each pin, like 2 and 13. So that's why not 35, but 20 and 19. Yep. So 2, this one is 2, yes. So let's put it like this around it, and then 20, and then it will go to 13 somewhere here. Yes, it's there. And then this should go to digital actually. Yep, number 2. And then this boot pin, where is it? It is 18. So that should be like that. And then let's have this. This is a low pass filter, we are measuring the current of the charger. Uh, yes. Do we also measure the battery? I think we need to measure the battery as well. Oh, I forgot that one. Or do we measure the battery in the MCU? Let me check. No, I guess we don't measure it. This is important. So we need to find the solution here. How do we do that? Uh, so let me just put a note. If this one doesn't work, we need to check it. This is the light sensor. Ah, this is charge. Okay. Is that the just charge monitoring pin? Yeah, this is just the charge monitoring pin. Why we don't monitor it? I forgot it, you see. Live is good enough, don't worry. Thank you so much, guys. No problem, I don't worry. I was just worrying about you actually. You don't like give any response. If it is clear and understandable actually from your side, it's important. Uh, One thing is like maybe like backlight enable and the display enable, we can just combine them, right? So if you don't enable the display, why would you enable the backlight? Then Türkçe olsaydı keşke. Arkadaşlar Türkçe de yaptık. Diğer videoları Türkçe izleyebilirsiniz. But anyway, this is in English. Okay, let me do this change there. Let me go to screen. So I remove this LED enable. I just bring this there. So both of them are on the same logic. But you need to check it actually if one is enable and one is enable. If one like logic one is enable and logic zero enable, then it will be a mismatch. Yeah. So you need to check it. I will check it after the actually live video. Check the check the logic. I just stated like this. And then I need to check which of these are like analog capable. Guys, I know Turkish is good, but I have done actually enough videos, and then I don't know. I mean, we are located in Sweden. I have everything actually related to these foreigners anymore, so I don't foresee or I don't see any actually benefit of having videos in Turkish anymore. I know my followers, most of the followers are Turkish, but I don't know. What was it? GD32. It's this one. Ha, Sinan, hangi delikler? Anyway, so I need to check the pin out um, and the functions. So we use the LGA footprint. I need to find an analog capable pin. Guys, you can improve your English too actually with this. It's like it's a lesson like you know So the one I did, PA5, if it is analog capable, let me check. PA, yes, ADC in 5. I got so happy, you know. I don't need to like, change it. Okay, so I need to do this low pass filter there. That actually creates stability and then eliminates the noise. So you should do it like for most of the circuits, most of the ADC inputs. And then I just do it like this. Yep, yes. So just throw it. Yep. And then ADC in 5. So let me put it here, the net label, and then this is also easy to remember in the during the programming. And then this just will be the battery connection. Hey, this is off the grid. Why not? Why? This is like half a mil off the grid. Let me just, yes, now it's corrected. And let me take the battery. Yes, the battery pin, battery voltage. And then put it here. But there will be one thing actually. So if the battery voltage is more than like usually the battery voltage is like 3.7 and it goes to 4.2, 4.3 sometimes. So in the in the in the MCU, the voltage level, I think it can maximum measure is 3.3. Usually it depends on the actually IDC reference. But there is a limit actually, absolute maximum ratings. So without checking, I'm saying this, but I need to check it, of course. So you need to check it as well. So you should go to a data sheet. Let's see the maximums. So if I can find the ADC, yes, I need to see the absolute maximum ratings and the recommended operating conditions. Yep, absolute maximum ratings. Analog supply voltage, you see, and the analog voltage in I need. This is the supply voltage. Yeah, it should be 3.3. And the power supply, electrical, external. I think we need to open the reference manual. I don't know. Not the clock. I need ADC characteristics, GPIO. This is just IO port. AC characteristics. No, it's not this one. ADC operating voltage is 3.3, typical minimum and maximum. Input ADC input voltage range. You see, it can go up to VDDA, which is 3.3 volts. So we found it. So in this case, what we need to do is actually we need to divide the voltage simply, right? We need to use a voltage divider. So I will just take a 10K and then use it as a voltage divider. So the voltage will be divided by 2. So if it is 4.2, it will be 2.1 maximum. You need to leave a little bit margin. Why? Because it can do peak. Let's say it can do 5 volt. Accidentally, there can be 6 volt, and then the half of it will be 3. But you can a little bit play and then adjust. But alternatively, we should be putting here components a protection diode, actually TVS here. So if the pin is 3.3 volt, you can do two different kind of actually protection. Let me show you and explain how it is. This is very common to use actually. Either you can use normal diode. Let's see, I am using this one. This one. So you can do like this. You can clamp the voltage to 3.3 and to 0 volt. In this case, if the voltage goes beyond 3.3 volt plus VF, you know, the forward voltage of this one, let's say 0.3 to 0.7, so it might be 4, and then it will be minus 0.3, right? Or minus 0.7. So it will keep the voltage within this range. If this voltage, at this point actually goes beyond the level, 3.3 level. So this is one actually solution. It's very common, and you can see it in a lot of actually schematics. But I'm gonna just use a TVS here, a small TVS. So a 5 volt one. So, oh, sorry, not 5 volt. I need to use 3.3 or 3.4. Not very on the edge. But I will. Oops, not there. Yes. Oh, it doesn't have the correct shape. I need to check these. Why they don't have these correct shapes? I don't know. I will need to adjust. We don't have this value here. Yes. Ah, yeah, these ones have. But this is too big. SMB is too big, right? SMA is the smallest among these SM series, I guess. What about this one? No, this is not something we want. This would be nice, but this doesn't have this. Okay, maybe it's bi-directional. That's why. Anyway. Okay, but we will need to do it, and then I will need to check this diode. I will put a note to myself. Check the diode. I like this type of actually like putting notes to the schematic. You can easily follow it like because you are working on the schematic, and then it's easy to see. Uh, Check the Zener or TVS diode. Yes, right. And then we just need to annotate the schematic. Yep. Then update the PCB. What? C37. Why? Let me find that one. Okay. I need to find 1 nano capacitor. The thing is, I have changed the actually library name, although it is the same library, so it cannot find the all drawn components, unfortunately. So I have to pick them again sometime. 0603 and then 1 nano or 10 nano is good. So this is 10 nano. I guess 10 nano would be okay. This place. Yes. And then these are tools annotate quietly and then update the PCB again. Let's see. This P3, I will fix it later. I told you already. Oops, no, we don't do that. Don't do that. So I have the new components here. Yep. They already came here. But no way, this is still too big actually. I want to use a smaller one. Maybe SOT 3 to 3. This is a very big one. I don't like it. I need to use a smaller one. But let's find it actually. I'm gonna like let me show you how I find components as well. For this board, I'm gonna use Chinese components. That's to make the board cheaper. I have done a lot of purchases actually in LCSC. It's very like I can't trust them. Uh, Diodes, TVS diodes. Yes, we want Zener diodes. Yes, and then it should be in stock, and then the just a single diode, right? No, not like combination with more diodes in a package, single package. And the Zener voltage should be 3.3, 3.7, and then 3. These ranges can be okay, right? But maximum 3.3. Why I select more? Because then I can have broader actually selection. Hmm. There is this one, which is from an Xperia. But let's select the cheapest one. I don't like this one. No, not not this ones. This one is a big one. Big one. Yep, this one. 3.4 volts. 323, SOT 323, but it's 3.6 volt. Maybe, but there's a small one. Let me check the data sheet. Power dissipation is like 200 milliwatts. Forward 0.9. Wow. This one, 3. Let's me check. This one is like more power, and then 3.3 volt exactly. So our limit is 3.3 because otherwise ADC will be saturated. Well, this is not for saturation. This is for protection. So you can leave a limit a bit, like it can be 3.4, 3.6, but you need to check the absolute maximum ratings of the MCU input. But I guess this is very well like within the limits, 3.6 and so on. But I think this looks suitable. Like I will use something like this. SOT 32T3. But do I have it here? Diodes. TVS. No, unfortunately, I don't have that one. I need to create it, but I know in this one, just a normal diode. Yes, it's this one. For just moment, I will just put this one, and then I will change it later. So then I don't forget. Check this another diode. Already my notice is there. So sometimes I don't like this annotation actually. So a lot of times it asks. Maybe it shouldn't ask. It should do it automatically sometime. I think there's a replace like component button, but anyway. Yep. Yep. You see, it's very small now. It's a reasonable size now. And D2, where is D2? Where did I put this D2? Let me check. It doesn't show this. Ah, it's here. Yeah, this is for the power, so this is okay. I have this component already in stock, so I'm using this usually mostly these ones they are in stock actually. But guys, I'm tired actually. I think we can stop here. I will actually do this layout placement, and then in the next video we can start actually routing the traces. and then let's hope next week I can finish this one and then send for production. Yes, guys. Do you have any question before we actually end the video? Do you like it? Don't forget to actually subscribe if you are not if you haven't done it already, and then like the video and share it as well. So you can help us like a lot with by sharing, liking, and subscribing. So I can create more and more actually this type of content. So I can get the motivation, right? So this all depends on the motivation because I don't earn money actually doing this. I like actually teaching and showing things that I know. I'm not maybe ultra expert, but I like actually showing it. Anyway, do you have any questions actually? If you don't, I'm gonna the finish the stream. Alp Electronics also offers like engineering services like PCB design, product design, hardware development, R&D. If you have any queries, you can also contact us through our webpage, which is in the link in the description. But for now, I think see you next week. I don't see any questions coming from you guys. Have a good evening, and then see you later.